Welcome back my dear friends. This is the TQM1 lecture series on NPTEL MOOC series, and we are doing the 36th lecture, which is the last week first class for this TQM1. I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, we are discussing in the last class, if you remember, I did mention about the cumulative sum charts and the exponential moving charts, and it was in the problem, even though we did not do all the problems in depth, but I did mention in quite a conceptual framework that both the first moment and the second moment can basically change in two ways. So, obviously, there would be 2 into 2 4 combinations. In the first case, the mean value is constant and the variance is constant. In the second case, the mean value is changing, the variance is constant. In the third case, the mean value is constant, the variance is changing, and the fourth case both are changing. So, obviously, that will mean that the level of importance which you will place on the past data, on the data which has already been collected, would basically increase or decrease depending on what importance you want to place. And if you remember the example which I gave for woolen clothes or the sale of fridges or coolers would obviously depend on which month they are, and obviously you will put level of importance to the past data accordingly. In the problem which we discussed, where the mean value was basically for the 20 observations were 10 and for the next 10 observations was 11, and based on that we found out the upper control, the lower control, and found out in the first 20 sets it was under control, then the next 10 there was a trend which was going out of control. So, based on that we are analyzing the problems in more details. The last 10 observations were drawn from a normal distribution with a mean of 11 and standard deviation as 1. Consequently, we can think of these last 10 observations and having been drawn from a process when it is out of control. The reason being that the mean value is shifting. If it is shifting, obviously there would be a trend which will give you that the overall central line is moving. So, the central line is moving. So, obviously with respect to the earlier part, the upper control and lower control would change, which would give the set of points based on which we are doing the reading would obviously be out of control or within control, depending on where into which respect you are considering the upper control line and the lower control lines, the set of points. So, it is continuing this, it says that is after the process and has experienced a shift in the mean of 1 sigma, because if the mean of 1 sigma has been there. So, obviously the overall value would be shifting from 10 to 11, and if it decreasing, obviously it will decrease from 10 to 9. The last 10 observations are plotted on the control charts. None of these points are outside the control limit. So, we have a very strong evidence the process is out. So, there are points are basically outside the control limits, and obviously it gives you an information the process is out of control. So, note that there is an indication that a shift of the process level for the last 10 points has happened because all but one of the points are plot above the central line. So, obviously it would basically mean that if the whole set of diagrams are above, obviously you would be aware that the overall trend is changing. So, what I mean by the trend is basically I will try to draw a line. So, consider this is the central line, this is the upper line, this is the control line. So, these are, say for example, the first set of data you have taken from here. If the next point it is basically shifting like this, so obviously the trend would be going, that is going an upward trend. So, which means the mean value is increasing. In case, let me erase it. So, this is the x axis, this is the central line, this is the upper control, lower control, and this is the set of points initially which you had, they were under control. Now, if the set of points are behaving like this, which means this is a downward trend. Another can be again use this chart is the case y axis, x axis, central line, the lower control, the upper control. Consider this is the point where the change has occurred. It may so happen the average is here, but is increasing. So, that means the variance by itself is increasing, but obviously we are not considering that, we are considering the trend here. So, obviously in the mean the standard deviation can increase or decrease. So, these 4 diagrams which I have discussed would be considered in different lights in the problem which you are considering. So, it states that these last 10 observations are also plotted on the control charts. None of these point plots outside the control limits. So, obviously, we have no strong evidence that the process is out control. Note that there is an indication of the shift of the process level for the last 10 points, because all but one of the points are above the central line. So, the set of points are above or the set of points are below. So, this is what the diagram which I tried drawing. If we rely on traditional signal of an out of control process, one or more points beyond a 3 sigma control limits, then the Shewhart control charts would have failed to detect the shift. The reason for this failure, of course, is the relative small magnitude of the shift. The Shewhart charts for averages is very effective if the magnitude of the shift is between the range of 1.5 sigma to 2 sigma. For smaller shift is not at all effective. So, that means we are not able to take care of the understand the overall problems which is basically affecting the shift and take corrective actions accordingly. Now, coming to the idea of plotting the cumulative sum charts, the CUSUM charts directly incorporates all the information in the sequence of sample values by plotting the cumulative sum of the deviations of the sample values from a target value. Suppose that the sample is size of n greater than 1 is collected and x suffix j is the average of the jth sample. So, obviously, depending on how many samples you have collected and each sample would have some set of observations, we will basically find out the averages. Then if mu suffix naught is the target for the process mean. So, obviously, the process mean would be fluctuating. So, if it is fluctuating, our main trend is basically to achieve our target, which is basically, say for example, mu naught. In the same way, say for example, you are filling jam bottles and the actual value should be 250 grams, but they are fluctuating above and 250 grams and below 250 grams, but in the overall process the jam bottle should be exactly 250 grams. So, this is our target value which you want to achieve. So, this is what is meant by mu naught or mu suffix 0 is basically the target for the process mean. The cumulative sum control charts is basically formed based on the fact that you want to find out the total cumulative sums of the differences between the averages which is happening for each subgroups with respect to the value of what is the target value. So, consider you have taken the first sample. The first sample, say for example, have 20 observations, average is say for example 20.5, and the average you want to aim is say for example 20. So, it will be 20.5 minus 20, and then you keep adding the values of the differences of the sample average with respect to the overall so called population average. I am using the word of population average, which may not be right in the actual true sense, but this mu suffix naught would give you some idea that where we are heading to and what is the overall population average you want to achieve based on the fact there is already fluctuation in the sample mean which you are trying to collect and in some groups. So, considering in the next sample again of 20 observations, the average is say for example 19.5 and the actual average which you are aiming is 20. So, it will be 19.5 minus 20, you added that up with basically the initial value which was 20.5 minus 20. So, you continue adding it and do it for all the set of samples which you have. So, once you find it out, you basically calculate the initial values of the CUSUM charts based on which you will do the calculations. So, now what are the ways to represent the CUSUM charts? Because they combine information from several samples, cumulative sum charts are more effective than Shewhart charts for detecting small process shifts, because those information which you are getting for each sub samples or samples and their averages with respect to the target. So, they would be changing, which would give you some information that in which direction the change is happening. So, even if they are small, they would immediately give you that information which is incorporated in your overall calculation. They are particularly effective with samples of sizes only n is equal to 1. This makes the cumulative sum control charts a good candidate for use in chemical and process industries, where the difficulty of collecting samples more than one is very vast. Or in, say for example, the level of destructive testing, you have only one sample which you can destroy to do the readings. And in discrete part manufacturing, with automatic measurements of each part and on online process monitoring directly at the work center. So, the number of observations which you can have are very limited, hence the sample size being small. Here where the CUSUM charts, there are two ways to represent CUSUM charts, tabular or the algorithmic form and the V mask form of the CUSUM charts. Of the two representation, the tabular CUSUM charts is preferable. We will not discuss the V mask CUSUM procedure. So, we will only concentrate on the tabular CUSUM format. The tabular or algorithmic CUSUM for monitoring the process means are as follows. CUSUM may be constructed both for individual observations and for the average of rational subgroups. So, let us consider xi be the ith observation of the process. When the process is in control, xi has a normal distribution with a mean which is given by mu suffix naught or mu naught, and the standard deviation is given by sigma. So, we assume that either the S, which is basically the standard error, is known, or that a reliable estimate is available. These assumptions are very consistent with phase 2 application of statistical process control. Given that the information is already available from the past, we can use that to estimate what would be the set of observation for the population of for the sample characteristics happening in the future. Sometimes we think mu suffix naught or mu naught as a target value for the quality of the characteristics of the random variable which you are trying to measure, which is x. This viewpoint is often taken into the chemical and the process industry when the objective is to control, say for example, x is the viscosity, or x is basically the level of strength of a raw material or flow of the raw material which is happening in the process industries, which you want to achieve. So, that is what is mu naught is. And consider in this case for the viscosity, we are measuring that, say for example, mu naught should be about 2000 centistrokes at a temperature of 100 degrees centigrade. So, depending on the temperature, we have already finalized what should be the viscosity level, based on which we will try to basically bring our overall process back into a certain value, which is basically mu naught, which you want to achieve. If the process drifts or shifts from off this target value, the CUSUM would basically will give the signal, and an adjustment is made to to manipulate the values such that to bring the process back into the target value, which is mu suffix naught or mu naught. Also, in some cases, a signal from a CUSUM indicates the presence of an assignable cause that must be investigated, just as in the Shewhart chart case. So, obviously, if there are assignable causes and those informations are coming when you are trying to plot the CUSUM charts and there are aberrations, obviously it will give you that information that there are some assignable causes for which corrective actions should be taken. We will consider the CUSUM or the cumulative sum values. The tabular CUSUM works by accumulating observations from mu naught that are above target and one statistic which is basically C plus, and corresponding they would be C minus. So, C plus would be accumulating the deviation from H naught and that are below the target, would be another one which is C minus. So, obviously, you will have some positive deviations or fluctuations above the average value, and there would be average means the mu naught value, and there would be some values going below, which would be this mu naught minus those xi values. Obviously, they would be negative, they would be given by C suffix minus. The statistics of C plus and C minus are called one sided upper and lower CUSUM values. So, they are given by this very simple formula. So, if you concentrate on these formulas, they will make sense to all of us. So, what for the C1 value, what you are trying to do is that you are trying to basically take the maximum of 0 or the deviation which is happening here. So, if you consider the deviations, so there would be some C. So, you would basically have a C plus value from the last data. So, you will basically try to calculate the deviations which is happening as of now, considering the total set of information which is coming from the last data, and if the value is greater than 0, obviously it will be a maximum of that, those two sets of values which you will consider in the next stage. So, if I am at the second set of values, I will basically take the first set, try to find out the maximum value and proceed to the next observation which is the third one. In the third case, I will try to compare with the second observation and take the maximum of that and then proceed accordingly. Similarly, when I am doing the negative part, that is the negative fluctuation, when it is below the average line, I follow the same policy, but in this case it should be remembered the values of mu naught minus k and mu naught minus k in the first case, one would be greater than xi and one would be less than xi, which is the actual values which are being observed at the ith reading, and they would be subtracted or from x naught minus k, or they would be x, and they would be added to the value of x mu naught plus k, depending on which side of the reading you are trying to take, whether it is the positive one or the negative one. So, k is usually called the reference value or the allowance or the slack value. So, whatever amount of slack you want to give, and it is often chosen about halfway between the target value mu naught and the out of the control values. So, in this case, if those values of k can be either plus or minus or some mod based on the shifting of the average value which is happening. So, if I am considering, let me consider the normal distribution in order to make things much clear. So, in the case you have the normal distribution, what you will do is that you will take a band, and within this band you will find out the fluctuation and do the calculations accordingly, or in one case it would be either on the upper side or on the lower side, depending on whichever view you are taking. You will basically do the calculations and find out the CUSUM values and do the calculations accordingly. So, with this so that we are interested in detecting it quickly. So, considering that that the k value would be the average. So, what you are considering is that positive fluctuation and negative fluctuation are of equal importance, or to be more precise, they are of equal quantum. So, if they are of equal quantum, obviously we will consider the half of the mod of the difference between mu 1 and mu naught. Mu naught is basically the target value. So, we can calculate k as given and do the calculations accordingly. So, if either C plus or C minus, which C plus is the positive deflection or positive movement, or C minus is the negative deflection or negative movement, they exceed the decision intervals, which is h, between which the band should be there, the process is considered to be out of control. So, if they are within the control, obviously we will consider that there is fluctuation, obviously that would be a part and parcel of the protection process, and we will consider that to be normal. But if the fluctuations are outside the band, obviously there are problems related to the readings, related to the assignable and unassignable causes, and obviously you will do take the corrective actions in order to rectify that. One rule of thumb to calculate h is to calculate h as 5 times the process standard deviation of sigma. So, if you remember, the sigma is the standard deviation of the population. So, in order to keep the total value within a band of plus minus 3 sigma. So, 3 sigma would be 6 sigma total deviation. So, if you are taking a value of 5 times the process standard deviation, it would technically mean, if you look at the tables, you are basically going, if you are considering a dumbbell shaped curve as a normal distribution, it will be going plus and minus 2.5 onto the right or the left, such that you are giving equal importance to positive deviation and negative deviation. Let us consider an example. So, these values are given. So, samples observations are 1 to 30. The xi values are given from 9.45 to 10.52. This is which is the first reading till the 30th reading, which is 10.52. And you basically find out the difference between these xi's and the xi's I1, I2, I3, I4 till I30 are the reading number. And this minus 10 is happening because you consider the average value, which is mu naught, is the target value which is 10. Based on that, when you find out the CIs are given as on the last column, starting from minus 0.55 to the value of 9.45. So, we are basically adding them up, adding those values. So, if you add up these values, obviously in the first case it is minus 0.555. In the next value is minus 2.01. So, obviously minus 0.55 gets added to that, that it becomes minus 2.56. In the next case again minus value is there. So, minus 0.71 minus 2.56 basically becomes 6 plus 1 is 7, 5 plus 7 is 12, 2 plus 1 is 2, 3.27. So, in the next value basically there is a positive one, which is basically the xi minus 10 is basically 1.66. So, 1.66 would be subtracted. So, I am taking the sign into consideration, it becomes 1.61. So, if I do the cumulative one, the last value basically comes out to be 9.45. So, once I have that, the solutions are with the value of 10.5. I find out the values as given, the 1 to 30 the first column, the xi values are given, and then if I find out the values of xi minus 10.5 which is the average, and then find out the C plus values and the corresponding n values which is the range values which I have discussed. Similarly, I do it in the last three columns which is given by the number b, which is the b set of observations. There I take the average value as 9.5, do the calculations accordingly, and there I find out C minuses, and there also I find out the numbers accordingly. Now, the observations and the values are explained accordingly. So, recall that the target value is basically mu naught is 10, the subgroup size is basically 1, because the 1 was the basically sample size, the process standard deviation is given as 1. And suppose that the magnitude of shift we are interested in detecting is given as 1. So, obviously, it would mean that we are trying to basically find out a detection of 1 into 1, that means sigma is the overall per unit. So, what is the number of times of sigma we will take, which is 1, which is basically multiplication value comes out to be 1. Therefore, out of control values would mean that the mu value which has now been possible is basically 10 plus 1, which is 11. So, in that case, see for example, if you are if suppose the magnitude of the shift we are interested to find out is basically of 2, then the value of actual deviations would be 2 into 1, because sigma is 1. So, it will be 2, and hence mu suffix 1 would be 10 plus 2, and the values would be calculated accordingly, which is 12. We will use a tabular CUSUM with a k value of half, because the size of the shift is 1. So, obviously, any plus and minus deviation you are giving equal weightages, which will be 1. In the case if it was 2, obviously the plus and minus deviation, if we give equal weightages, it will come out to be 2 divided by 2 is 1 on each side. Based on that, if we consider h as 5, so here the calculations will give C1 plus value, C1 minus values would be given accordingly. So, which is the calculations as shown. So, this would be the value of C1 plus, this would be the value of C1 minus, and since k value is basically 0.5, because you remember we took the detection shift magnitude of shift to be 1. So, 1 into sigma, which is 1, is basically 1 only. So, 1 has to be the total detection on both on the left hand side and the right hand side would be 1 divided by half. So, hence k is 0.5. And based on that mu naught, which you already knew, which was 10, you found out mu naught is 10, and then given that xi1 is 9.45, we do the calculations and find out the C plus and C minus values and continue doing the calculations accordingly. So, C1 minus value would be calculated as 0.05 for period 2. Also, we will find out the values of x2 has changed, which is 7.99. Then C2 plus value would be 0, C2 minus values would be again calculated, comes out to be 1.56, and we will continue doing the calculations accordingly. Conclusions from the charts. The upper charts CUSUM at a period of 29 is basically given as 5.828. Since this is the first period in which C1 plus is greater than H, the H value which you have taken is 5, we would conclude that process is going out of control at this point only. So, obviously, H value would dictate to what level of efficiency you want the calculations to be. So, if you want very strict or very lenient, so obviously the H value would be taken accordingly, and hence the C plus I values would basically cross H or never cross H, depending on what is the level of efficiency of values of H you have considered in your problem. The tabular CUSUM also indicates when the shift probably has occurred. So, obviously it is occurred at the 29th value or of the reading. The counter n plus records the number of consecutive periods in the upper side CUSUM C plus I rows above the value of 0. So, here n plus would be basically be 7. So, at the period of 29, which would conclude that we would conclude the process was last in control at a period of 29 minus 7 22. So, obviously if 7 times it was basically going plus plus plus, that means there is slowly a trend of shifting which is happening. So, it in 29 reading it basically crossed the overall value of h. So, let me draw it and give a intuitive feel. It is too thick. So, this is the central line. So, this is the upper line, this is the lower line. So, the values are fluctuating. So, this say for example is the 22nd reading at which it was under control, and these values have been 7. So, there has been increasing trend in the numbers of values which are going up. So, obviously it could be down also, and if I consider the value at the 29th reading, it will be the value of C plus would be greater than h, such that it will give me, and that at the 29th value the overall the control is above the control upper control limit. So, hence the trend which was happening is really in the direction, I am not saying wrong or right, it is happening in the direction such that some corrective action and some necessary importance or some soul searching needs to be done in order to understand that why the change is happening. So, continue, I will again read it. Since n plus is 7 at the period 29, we would conclude that the process was last in control at the period 29 minus 7, which is 22. So, the shift likely occurred between the period of 22 and 23 and started happening in such a way that at 29th reading it really crossed the boundary. Boundary means the upper control limit. So, it could happen on the lower side also, and if you change the h values, obviously it will give you at what number of reading the changes are happening and how many such readings the trend has been there on the upward trend and the downward trend, depending on the shift has occurred. So, in situations when an adjustment to some manipulative variables is required in order to bring the process back to the target values, which is mu naught. So, obviously the new process would be following a shift which has to be taken into consideration. So, consider that this value which we have calculated. So, for C plus is 5.28. So, 5.28 was greater than 5. So, based on that we took the corrective action. So, if I find out the mean now, this mean value has to be calculated and estimated. So, if the mean value which is estimated is based on the ratios which you have found out, which is mu naught, which is the initial target value, plus k value which was half, plus or minus depending on whether it is greater than or less than the value of C plus or C minus, you will find out the ratios of C plus by n plus or C minus by n minus, and you will find out the mu hat, which is the new values accordingly. So, they come out to be 11.25. So, we will continue discussing the exponential moving charts and also discuss in very brief the cumulative charts in the 37th 38th lecture accordingly. Thank you very much and have a nice day.